Hello, my name is Arnaud Soulier and I teach ICS cybersecurity. So I wanted to do a short video to discuss Hacker Summer Camp. I was lucky enough to attend Black Hat and DEF CON in Las Vegas this past August. It was a very busy time for me because I was training at Black Hat. My training Industrial Control Systems Build, Break, Secure was sold out, so I had 20 attendees to my training for 4 days, so that was kind of exhausting, so I wasn't able to attend a single talk or even go to the arsenal to check out the new tools. And then I was supposed to teach 2 workshops at DEF CON, so I had to prepare and do, I would say, the last touches to the content for those workshops. The first one was the traditional pen testing ICS. I've been doing that one with Alexandrine for several years now, so of course we try to update it a little bit to make it easier for participants, and it was a great success. As always, people love to be playing with PLCs. They love to learn how to talk Modbus and being able to stop the train and use the robotic arms to capture the flag. So that was a lot of fun. And the day after that, I did a new workshop based on the top 20 secure coding guidelines for PLCs, and I just want to expand a little bit on this one. So I'm not gonna do a full video on the top 20 PLC secure coding guidelines, but the idea is to have something like the OWASP top 10 that we have for web application, but applied to PLC coding, I would say. So what I did for this workshop is that I tried to implement most of the rules in a PLC simulator, and when you give trainings on PLC programming, it's not always easy to have a realistic system that people can use to create their own environment. So that's why this year I decided to copy what I do for my trainings and have another version for the workshop, and it's a process simulation. And this is what I'm going to detail next. Okay, so the project I wanted to talk about today is called Simple Process Simulation, and as the name suggests, it aims at simulating an industrial process, so we can use that during trainings and awareness session to have something visual when we learn how to program a PLC or when we learn how to securely program a PLC. How does it work? Well, it's very simple. It's composed of several components, so let's zoom in. Basically, you have an HTML5 graphical web app, some JavaScript, and most of the heavy lifting is done by the JavaScript. Everything regarding simulating the actual values of the process is done in JavaScript. This web page, and I will show it to you later, is really, you have to think of it as read-only. You cannot interact, it's only meant to display the state of the process. This JavaScript interacts with a Python interface using HTTP, so I have a very basic Flask endpoint, HTTP endpoint, and so JSON payloads are exchanged between the two, and this allows the simulation to communicate with the PLC, because this process simulation only simulates the process, not the PLC part. So you can use a real PLC or you can use a PLC simulator. That's what I usually do. To have a complete environment. I also sometimes add a SCADA software, and so we can have a real environment. So let's take a look at what it looks like in real life. So this is a VM. It's hosted in the cloud by SkyTap. Maybe I'll talk about SkyTap later on. It's a great solution, I think, for trainings and providing environment to students. So on this VM, it's a Windows 10 VM. I'm using, as always, Schneider SoMachine Basic as the PLC programming software and PLC simulator, because that's the software that is used to program the TM221 PLCs that I have. And so I'm just using that. I have created a program here to control the simulation. It's not perfect, but it kind of works, and that's okay for what I'm trying to do. So the PLC is running at the moment. And here we have the simulation. So the simulation has a small feedback here, and you can see if the valves are closed, open, if the motors are stopped or running, etc. Then for this environment, I also created a SCADA environment to be able to control the process. So I have a few values that I want to use, and I'm just going to start the batch and start the process. Okay, and I go back here. So how does it work? It's a simple mixing process. So first, the first valve is open to fill it with one type of liquid, then the second valve. Then when we reach the expected value, we start mixing for the expected duration at the expected speed. And so I think I set it up to 45 seconds maybe. Yes, 45 seconds. So let's go here. If I go to the PLC code somewhere, I should find a timer that has the 45 preset value. So here it is. So that's a timer and it's preset to 45. We already have 33 seconds that have passed. Okay, and so when the agitator stops, we will go to the next step of the project, which is opening the outlet valve and pumping the mixed product into the destination tank. And once the destination tank is full, then the process is, the batch is done. So let's see, 900, I think it's 1000 liters. Yes, mixing operation complete. So as you can see, it's really easy. It's really simplified as well. So the idea is not to simulate how the fluid will flow in the pipes. Absolutely not. It's to have something very basic, but that provides graphical feedback to people programming a PLC. So how does it work in terms of code? So again, it's really basic. There's an app that a Python app, and I already mentioned it's a Flask app. So basically, the default route is to display the simulation, and then you have the update endpoint that does something very simple. It connects to the PLC, and here it's for a Modbus PLC, Modbus TCP. So you can actually use a real PLC. It will work as well. Just configure the IP address here. Okay, and so it will write some values, read some values, really basic things. So it takes the values, the process values from the JavaScript simulation and updates the PLC, and it takes the control values from the PLC to give that to the JavaScript simulation. So really basic. And in terms of JavaScript, that's where most of the real interesting things happen. Here I have some constants that you can define to accelerate the process, define, I would say, the size and the volume of the tanks. And then I think starting over here, I tried as much as I could to define the different simulated actions. For example, if you open one of the inlet valve, the volume of the tank increases. Okay, things like that. For example, I also have to define the possible undesired outcomes. For example, overfilling. So if the process said that the value is higher than the capacity of the tank, of course, we want to stop the process and say, okay, there's something wrong. Okay, so this could be adapted to a lot of different processes. Mixing is one simple operation. That's why I chose that. And of course, you can improve that as you want. And the rest of the code is just updating the visuals. So again, really easy to understand. I aimed at something that's easy to use as well and easy to modify. So that's available on my GitHub here. I don't think there are too many requirements, just a few ones. And I would love to have some feedback and people using that to do something else, or providing or suggesting additional errors or process undesired outcomes, for example, or something to refine, I would say, the simulation so it's more realistic, I would absolutely love that. And if you're looking for alternative solutions, of course, Factory IO is a very interesting one. It's a commercial solution that is designed for PLC training, actually. So let me click on that quickly. So as you can see, it's in 3D, it's way more advanced. I tried it, it's good. It doesn't run well in my cloud VMs because you need some graphical computing power, but it's way more advanced than what I do. So maybe that's for you. And you also have additional solutions that I've not tried. I think the one from Fortified, I didn't try it because it required too many VMs. So here we have something basic. I think you can test it, and I would love some feedback. Well, that's it for today. I hope you enjoyed the video. I hope that you will try out my new simulation tool, and see you soon.